Hello guys, welcome back. This is your educator Vinas and I welcome you all on this very amazing platform of Physics Wala, right? I hope you are preparing well for your upcoming exams and I also project and I also pray that you must score very well in your upcoming examinations, right? So on this a very light note, I would like to say without wasting much of your time, let's start our today's point of consideration or today's point of discussion, and that particular point of discussion will be a chapter from physical chemistry point of view, and that particular chapter is none other than it's your redox reactions, right? So you must be quite familiar with this particular term, that is redox, right? Because you are just coming from your class 11th, right? Just coming in class 11, and in class 10 you have just a brief idea about redox reactions, right? So let's start our today's class, and today's class will be totally based on two major segments. First segment is how to calculate a oxidation number of a given compound, right? So what is oxidation number, how to calculate oxidation number, what are the rules of oxidation and all, blah 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 blah, right? So all this in a consideration or in a nutshell, we'll be discussing all those rules, all those phenomena, all those like jugards and all to how to find the oxidation number, as well as we'll be also considering, or we also be finding that how to balance a given reaction in acidic medium, in basic medium, as well as in neutral medium, right? So there are two goals that I'm setting for you, and that two particular goals are, first of all, we'll be discussing about your oxidation number, right? First of all, we'll be discussing how to find the oxidation number, right? And secondly, we'll try to figure out that how to balance the chemical reaction, how to balance a chemical reactions in two basic mediums, basically in two mediums, right? It be your like in acidic medium, as well as in basic medium, right? In basic medium, right? So with this, let's start our today's class, and today's point of first goal or today's point of first discussion, and that particular topic is your oxidation number. With the oxidation number, that how to calculate oxidation number, what is oxidation number and all. Like oxidation number is defined as, guys, just listen here. What I'm trying to say, oxidation number is defined as the real or imaginary charge which is present on a given atom, right? Just repeat again with myself. Just repeat with myself. Oxidation number is defined as the real or imaginary charge which is present on a given atom, and that real or imaginary charge is defined as your oxidation number, right? I hope you got the point. Oxidation number is defined as the real or imaginary charge, which is present on an atom, right? So whatever the real or imaginary charge which is present on an atom, it is also called as, or basically it is called as your oxidation number. Sir, it is not clear, just cite an example, right? So we have lots of example, right? Let's say I have an atom like sodium, right? I have atom of sodium, right? And I'm saying I have a sodium ion, right? So this is Na plus ion, right? Sodium ion is your Na plus ion, right? I have a magnesium 2 plus ion, right? I have a magnesium ion. I have an aluminum ion, right? So you people are seeing, what you people are seeing, a charge is seeing, whatever the charge which is visible by a naked eyes, what I'm trying to say, whatever the charge which is present on an atom and that particular charge is visible through naked eyes, that particular number or that particular magnitude of that particular charge which is present on an atom, that particular that particular number is what we call as your oxidation number. Let's say, what is the charge which is present on a sodium atom? Sodium ion. So what is the charge which is present on a sodium ion? It is +1, right? So the oxidation number will be +1. And if you just come to the point, by definition, it is the real charge. Why it is called as real charge? Because this particular charge is visible through naked eyes. So if charge is visible through naked eyes, then we'll be saying it as, this particular charge is your oxidation number. Similarly, I have a magnesium 2+ ion, and in magnesium 2+ ion also, the +2 charge is visible by naked eyes, right? So if this +2 charge is visible through naked eyes, so what will be the oxidation number? So it will be your +2, right? Now it's your turn, right? It's your turn. What is the oxidation number of aluminum 3+ ion? Yeah, you guess it right. Yeah, you guess it right. It is your oxidation number is your. So oxidation number is your. It is your oxidation number is your +3 charge, right? So what I'm trying to say, whatever the charge which is visible through naked eyes, then that particular charge is what we call as your oxidation number. But in contrast, I have a compound, let's say HCl. Now just tell me one thing. What is the charge you people are seeing in HCl compound? Have any charges there on that particular compound? Is there any real charge which is present on a given compound? None. It is not visible through naked eyes. That means whatever the charge which is not visible through naked eyes, and you have to conceptualize through internal feelings, then that particular charge or that particular number is what we call as your imaginary charge. Let's say I know a very simple concept of electronegativity, right? Out of H and out of Cl, that means out of hydrogen and Cl, which is more electronegative, then you people will be saying, sir, it's very simple, sir. Chlorine is more electronegative as compared to hydrogen. Yeah, you guess it right. So if chlorine is more electronegative, right, chlorine will acquire this, like chlorine have a tendency to pull that state of electrons towards itself, right? So in that process of time and in due course of time, there will be a partial negative charge and there will be a partial positive charge. So what we have seen, like initially the charges were not visible through naked eyes, but through our conceptualization, through our concepts that we have read previously, we have generated a charge that Cl, in HCl compound, Cl possesses negative charge as well as hydrogen possesses positive charge. So these two particular charges, which is an imaginary charge, then if there is an imaginary charge, we will be saying that imaginary charge which is present on an atom is called as the oxidation number of that particular atom, right? So what is the oxidation number of? So what is the oxidation number of chlorine in HCl? It's simple, sir. There is a partial negative charge which is an imaginary charge. So oxidation number of chlorine is how much? It is your -1 charge. Similarly, what is the oxidation number of hydrogen in HCl compound? Sir, it's very simple. Oxidation number of hydrogen is +1. It's quite simple, right? I hope you got the point what I'm trying to say, that what is oxidation number, right? So oxidation number is quite simple. It's the real or imaginary charge which is present on a given atom, then that particular charge which is present on a given atom is what we call as your oxidation number, right? I hope you got the point what I'm trying to say, right? So now let's move forward and let's discuss what is an oxidation reaction and what is a reduction reaction, right? So let's define what is oxidation reaction and what is reduction reaction, right? Because these two terms are quite clear because you have already read about in your class 10th, right? Like I'm trying to ask, what is an oxidation reaction? What is an oxidation reaction and what is a reduction reaction, right? So when you people in class 10th, your teacher must have said you, or your teacher must have given you ideas about what is an oxidation and what is reduction. Then in my teachers, when I was in class 10th or class 9th, my teachers used to say about oxidation like So when my teachers used to ask what is oxidation, then I'll be like, sir, ma'am. And I used to answer like, ma'am, oxidation is defined as gain of oxygen, right? It is also defined as a removal of hydrogen. And what is reduction, sir? Reduction is defined as, ma'am, reduction is removal of oxygen as well as addition of hydrogen. So these two terms is quite clear. This is the previous definitions of oxidation and reductions, which I said that oxidation is defined as addition of oxygen and removal of hydrogen. And what is reduction? Reduction is defined as addition of hydrogen and removal of oxygen, right? So, and these two particular definitions were like Pareto terms or Pareto definitions. Now the modern definitions in which I am interested and you shall also be interested, we'll be discussing it now, but let us write that two previous definitions of oxidations and reductions, right? So what is oxidation? How we used to define in the previous, in our junior classes? Oxidation is defined as addition of oxygen, right? It is defined as addition of oxygen, as well as it is also defined as removal of hydrogen, right? I hope you get the point. Now what is reduction? Just a vice versa of it. Reduction is defined as removal of oxygen, right? And the second definition that I'm interested, that is your here we are removing the hydrogen, but here in reduction will be addition of hydrogen. This is addition of hydrogen. But to make it very clear, these two definitions were the conventional definitions or the very Pareto definitions. But in modern era, in your era, in the world of contemporary society, the definition has been changed. Now we used to define oxidation in terms of losing of electrons and gaining of electrons, right? Now what is oxidation? Oxidation is defined as loss of electrons. What I'm trying to say, let's listen this very clearly, right? Just listen properly what I'm trying to say. Oxidation is defined as loss of electrons and reduction is defined as gain of electrons. Make it very clear. Oxidation is defined as loss of electrons and reduction is defined as gain of electrons, right? So what is oxidation? Oxidation is defined as loss of electrons. Loss of electrons is called as your oxidation. A very simple example. Let's say sodium is there. Let's say I have a sodium, right? I have a sodium in the gaseous state, right? Now in the very first animation enthalpy of sodium will be like, this is your Na plus and it will lose an electron. So since sodium is losing an electron, that means a loss of electron is defined as your oxidation, right? Similarly, I have a magnesium ion or magnesium gas, right? When it loses 2 electrons, it will be like Mg2 plus gas plus 2 electrons, right? Here it is losing 1 electron, here it is losing 2 electrons. So loss of electron is what we call as your oxidations, right? And this was the modern definition. Here I am talking about the modern definition. Of oxidation, right? So according to modern definition of oxidation, loss of electron is what we call as your oxidation, right? Similarly, what is reduction? So reduction is also very important. Reduction is also very simple. So reduction, what is reduction? Reduction is defined as gain of electron. Like reduction is defined as, what is reduction? It is defined as what? It is defined as gain of electrons. Right? It is quite simple. You have a simple examples. Let's say I have a very simple example. 2Cl minus is there. When it accept 2 electron, it will convert into Cl2 gas. Right? Here you are saying that chlorine is accepting 2 electrons and it is getting converted into Cl2 gas, right? Here I have also very simple example, 2H plus ion is there. When it will accept 2 electron, it will convert into your H2 gas, right? Similarly, I have a chlorine ion. Similarly, I have a fluorine ion, right? I have fluorine. When it accepts an electron, it gets converted into your F minus ion, right? This is also in gaseous state and it is also in gaseous state, right? So here what you people are seeing, you are seeing that there is gain of 2 electrons, here gain of 2 electrons, here gain of 1 electrons. So gain of electrons is what we call as your reduction, right? So these two terms is quite clear. I hope you have got the ideas that what is oxidation and what is reduction. Now the very important term, that is your redox reactions. Now what is redox reactions? Now what is redox reactions? Now what is redox reaction? So redox reaction, what is redox reaction? Redox reaction, what is redox reaction? What is redox reactions, right? So redox reaction is nothing. It is defined as those kind of reaction. It is defined as those kind of reaction, it is defined as those kind of reactions. It is defined as those kind of reactions. It is defined as those kind of reactions in which oxidation and reduction reaction, takes place simultaneously. Take those reaction in which oxidation and reduction reactions takes place simultaneously, then those particular kind of reaction is what we call as your redox reactions, right? I'm just repeating it again. That's those reactions in which oxidation and reduction reactions takes place simultaneously, then those particular kind of reaction is what we call as your redox reaction. To make it very clear, I have a very simple example. Let us go through a very simple example. Let's say I have a very simple example. Let's say I have an iron that is present in solid state. Here it is, you're reacting with copper sulfate, which is present in aqueous state, right? So what do you think? What will be the rate of reaction? What will be the product of that particular reaction? So since you know that iron is a very reactive metal as compared to copper, right? So reactive metal will displace non-reactive metal from its salt, like it is called as your metal displacement reactions, right? So what will happen? The product will be your FeSO4. Here it will be your FeSO4 plus Cu solid, right? And it will be present in aqueous state. So what you people are seeing, the oxidation state of the element which is present on its elemental state is 0, right? And here the oxidation state of copper is +2. Like we'll be coming to the topic that how to discuss oxidation state. Just to make it very clear, just to give you the feel of what is oxidation state, I'm just writing the reaction, right? Or what, just to give you the feel of redox reactions, I'm just writing the reaction. So no need to bother about sir what sir is writing, right? It's a very simple thing, right? So if any element is present in its elemental state, the oxidation state will be 0. Now, if you know the funda how to find the oxidation state, you will came to the conclusion that copper has a +2 oxidation state. Similarly, iron has your +2 oxidation state, and here copper is present in elemental state, so oxidation state will be 0. Now, just see one thing. Here, iron is going from 0 to +2. Here iron is going from 0 to +2 oxidation state, and copper is undergoing from +2 to 0 oxidation state, right? Here iron is going from 0 to +2 oxidation state. That means your oxidation number is increasing. And here what you are trying to say, or what you are seeing, you are conceptualizing, or what you are visualizing, that here copper is undergoing from a +2 oxidation state to 0 oxidation state. So oxidation number will be your negative, right? So now let us very clear. Here what you are seeing, here there is increase in oxidation state, and here there is decrease in oxidation state. Now just go to the back slide, and here I also need to write also need to write a very simple thing, that this is also definition of your, this is also the definition of modern way to define oxidation and reduction. So oxidation is defined as, according to the modern concept, oxidation is also defined as gain of electrons. Oxidation is also defined as gain of electrons is called as your oxidation. Gain of electrons not, it is gain in oxidation से या increase in oxidation state. It is defined as increase in oxidation state. Increase in oxidation state is defined as your oxidation, right? Similarly, what is reduction? Reduction is defined as decrease in oxidation state. It is defined as decrease in oxidation state. It is defined as decrease in oxidation state. So increase in oxidation state is defined as oxidation, whereas decrease in oxidation state is defined as reductions, right? In the previous slide we have seen that oxidation is defined as loss of electron and reduction is defined as gain of electron. Similarly, oxidation is also defined as, in terms of oxidation number, increase in oxidation number is defined as oxidation and decrease in oxidation number is defined as reduction. Now tell me one thing, in this particular reaction, Rn is undergoing from 0 to +2 oxidation state. That means here oxidation is taking place. Oxidation is taking place, and here copper is undergoing from +2 oxidation state to 0 oxidation state. That means here reduction is taking place. And if you are observing the reaction in a very minute way, you will come to a conclusion that in the same reaction, oxidation is also happening and reduction is also happening. So that means those kind of reaction in which oxidation and reduction reaction takes place simultaneously in a particular reaction. So those reactions in which oxidation and reduction reactions take place simultaneously, then those kind of reaction is what we call as your redox reaction, right? I hope I am clear what is redox reactions. So redox reactions is defined as those reactions in which oxidation and reduction reactions takes place simultaneously, right? So if you come, like, this is what the chapter is all about, redox reaction. All those kind of reaction in which oxidation is also taking place, reduction is taking place, that too both are happening simultaneously, and those branch of science is what we call as your redox reactions, right? Now, how to find oxidation number? So there are certain rules of finding an oxidation number. Let's say the very first rule of finding an oxidation number is rules for finding oxidation number. Rules for finding an oxidation number, and the very first rule is oxidation number, and the very first rule is rules for finding an oxidation number, and the very first rule is oxidation number of hydrogen is usually taken as +1, but if it is present in hydride form, then oxidation state of hydrogen is taken as -1, right? So the very first rule is hydrogen is usually present in +1 oxidation state, but if it is hydride, it will be your -1 oxidation state. This is the very first rule. Now second rule is oxidation number of oxygen is usually -2. Oxidation number of oxygen is usually -2, but in peroxides it is -1. In superoxide it is -1/2, and in ozonide it is -1/3, right? So I hope it's a very simple rule that if hydrogen is there, it will be present in +1 oxidation state. If it is a metal hydride, in hydrides it will be a -1. Similarly, if oxidation number of oxygen is usually -2, but if it is present in your peroxide form, it will be your -1. It will be present if it is present in your superoxide form, it will be your -1/2. It will be, if it is present in ozonoid form, it will be your -1/3, and so on. Right? Rule number third suggests that oxidation number of alkaline earth metal. Oxidation number of your alkaline earth metal is +2, as well as oxidation number of your alkaline metal is your +1. Right? So rule number 3 is oxidation number of alkaline metals. Oxidation number of alkaline metals is your +1, as well as oxidation number of alkaline earth metal is your +2. Right? This is rule number 3. Now, rule number 4 is oxidation number of fluorine. Oxidation number of fluorine is always -1. Is always -1. Whereas oxidation number of halogens is usually -1, but varies from -1 to +7, right? It varies from -1 to +7, right? So here are some rules, and in that particular series of rules, I have 4 to 5 rules, such as first rule says that oxidation number of hydrogen is usually taken as +1, but if it is present in your hydride form, it will be your -1, right? Similarly, oxidation state of hydrogen is usually -2, but if else it is present in your peroxide form, it will be your -2. If it is present in your superoxide form, it will be present in -1/2. If it is present in your ozonoid form, it will be your -3, right? Now, the other rules of your oxidation number is oxidation number of your alkaline metals, that is your group 1 metals, is +1, as well as alkaline earth metal is taken as your +2, right? Fluorine has oxidation number of -1 always, because fluorine is the very most electronegative element in the periodic table, so it will always acquire -1 charge, so the oxidation number of fluorine is always be -1. But if I compare the rest other halogens, the oxidation number varies from -1 to +7, right? Similarly, the oxidation number of nitrogen is usually -3, but it can vary from -3 to +5. Other rules, such as the oxidation number of all the elements in a compound is usually taken as 0. And the very next rule is oxidation number of an ion is equal to the charge present on that particular ion, as well as any element which is present in its elemental form or any other allotropic form is taken as 0. So these are the rules of finding an oxidation number. Let us define, or let us visualize, or let us conceptualize these rules into a particular example. And I am taking a very first example, and this particular example is your sodium dichromate. So let us find the oxidation number. How to find the oxidation number? Find the oxidation number. Find the oxidation number of underlined atom or underlined element, right? So find the oxidation number of underlined element or atom, right? And the very first example is find the oxidation number of K2Cr2O7, and the underlined atom is chromium, right? You have also need to find the oxidation number of manganese in KMnO4. You need to find the oxidation number of sulfur in H2SO4. You also need to find the oxidation number of iodine in Ki3. You also need to find the oxidation number of rest other compounds. Let's say any example. Let's say NS3. What is the oxidation number of your nitrogen in ammonia, right? So let us first solve this type of examples, the simple examples, then we'll just complicate the reactions, and then we'll be handling some complicated examples, right? So first of all, we need to go through the very basics, right? If our basics is clear, then we can majorly sort it out, right? And the very first example that I have given is your K2Cr2O7, that is K2Cr2O7, right? So the rule is, if you're not like those underlying atom, take it as X, right? Because we need to find that underlying atom, so just take it as X, right? So now, what is the oxidation number of potassium, right? I have said now, potassium belongs to group 1 metal, right? So any metal which belongs to alkaline metal, this oxidation number is taken as +1, right? How many potassium is there? So there are 2 potassium, sir. So 2 into 1 plus. We need to find the oxidation number of chromium, so let it be X. How many chromiums are there? 2 chromiums are there. So this is 2 into X. Now, what is the oxidation number of oxygen? Usually it is taken as -2. So how many oxygen is there? 7 oxygen is there. So 7 into -2, right? Now, I have also said an example or rule that sum of oxidation number of all the elements in a compound is taken as 0. So what it will equate with 0, right? Now, this is 2 plus 2x minus 14 is equal to 0. Now this is all about basic maths, right? So 2x is equal to 14 minus 2. So x is equal to what? 12 upon 2. It is coming out to be your +6, right? So oxidation number of chromium in K2Cr2O7 is coming out to be your how much? It is coming out to be your +6, right? Similarly, we'll also find the oxidation number of manganese in potassium permanganate, right? This compound is called as potassium permanganate. So we need to find the oxidation number of manganese, right? So for the underlying atom, and what is the underlying atom? That is magnesium, right? So take it as X, because you need to find the oxidation number of magnesium. So take it as X, right? So how to find what is the oxidation number of potassium? Since potassium belongs to group 1, right? So it is taken as 1 into 1. Why it is taken as 1 into 1? Because only 1 potassium is there and oxidation number of potassium is +1, right? So this is 1 into 1 plus how many manganese is there? 1 manganese is there, and we need to find the oxidation number of manganese. So let it be X, right? So X plus how many oxygen is there? 4. What is the oxidation number of oxygen? It is taken as usually -2. It is taken as 0, right? So this is 1 plus X minus 8 is coming out to be your 0. So this is your 1. By now this basics maths, this X is equal to 8. Now it is called as X. Now this is 8 minus 1. It is coming out to be your +7, right? Similarly, now here how this is the way to find the oxidation number, and majority of question in redox reaction has been asked that what is the oxidation number of this particular compound, that this particular element in a particular compound, right? In this way, like the way I have given you examples, right? Now let us solve the very last example and then we'll wind up our today's class, that is your H2SO4. Now you need to find the oxidation number of sulfur in H2SO4. Now according to our rule, how to solve? For the element we need to find, let it be X. Now how many hydrogens are there? 2, and oxidation number of hydrogen is usually +1. So 2 into 1 plus X plus how many oxygen is there? 4. 4 into -2, it is taken as 0. So this is 2 plus X minus 8 is coming out to be your 0. So this is X is equal to 8 minus 2. X is coming out to be your +6. So oxidation number of sulfur in H2SO4 is your +6, right? I hope whatever I have given you from my side, it has been clear, right? Although if you have any doubt regarding whatever I have given, just go through this lecture again, just recap this video lecture again, and if you have any doubt, you can pin it in the comment box. I'll surely read it and I'll surely make your doubt clear, right? But for today's class, I hope it's enough, because it's like already in half an hour and all, right? So it's better to just wind up our today's class. We'll meet again tomorrow, and we'll continue our further classes based on the redox reactions. So till then, thanking you all, and bye bye, take care.